The entire intestinal tract, the small intestinal tract, is lined with something known as circular pliques. Now, the circular pliques are projections that come off of the mucosa and sort of line the entire structure in a way to give them a more rugged look. And the composition of these pliques are more and more in the jejunal area as compared to the duodenal and the ileal area. The typical mucosa of the small intestinal tract is made up of the mucosa, then we have the submucosa, then we have the muscularis externa, and lastly we have the serosa or the adventitia. The mucosal layer is further divided into the epithelia, then we have the lamina propria, and lastly the muscularis mucosa. A typical intestinal mucosa is made up of intestinal villi, and the plural of a villi is known as a villus, and there are millions of intestinal villas that are present inside the lumen of the intestinal tract that are visible to the naked eye, and their main job is to increase the surface area of the entire structure. Let us further take a look onto the villus. So that's the typical mucosal villus right there. And surrounding the entire structure is the epithelium. There are certain specialized cells that are found inside the villus that help in the secretion and aid in the process of digestion. So the first type of cells that we're going to be seeing are known as enterocytes. Enterocytes line the entire villi. And if you look at it closely, you can see that an enterocyte is about a 20 millimeter long cell, which is elongated and cylindrical, with a nuclei that is an elongated nuclei that is approximately at the basal region. Then we can notice that around this entire structure there are certain entities known as microvilli. Now these microvilli are very small and measure about 1 millimeter and are about 3,000 in one particular cell. The lifespan of a typical enterocyte is about 5 days, after which it is renewed by the basal stem cells. The enterocyte is responsible for secreting a thick glycoprotein coat around itself, and the upper layer of this glycoprotein coat is covered in mucus. Now we know that the proximal part of the small intestinal tract is the duodenum, and the duodenum is actually at all times is filled with intestinal fluids and mostly gastric fluids like the pancreatic juice, and then we have the gastric juice, which are quite acidic in nature. So we really need to protect the intestinal lining from all of these acidic enzymes, and in order to counter-react the effect of all of these acidic enzymes, there is a need for a glycoprotein layer to protect the lumen of the intestinal tract. So hence the glycoprotein coat. The other type of cells are known as the goblet cells. Goblet cells are most common and increase in number as you go distally into the small intestinal tract. So they increase in number passing from the duodenum and become highest in the distal ileal region. And if you look at a typical goblet cell, you can notice that it is small and is present along with the epithelia, along the lining of the epithelia, and also in between the enterocytes. And it has a basally placed elongated nucleus with a few apical microvilli. Also, you can notice that it secretes mucin. Now, mucin is very important for lubrication and also prevents the desiccation or the drying of the intestinal tract. So it lubricates the intestinal tract and secretes mucin with the help of apically placed mucin granules. The other type of cell that is found inside the intestinal villi is also known as the M cell or the microfold cells. Now, microfold cells are found near lymphoid aggregates or lymphoid tissue. if you look at a typical microfold cell or an M cell, you can see that it's cuboidal in shape. And as the name suggests, microfolds. There are microfolds on the or invagination on the apical surface of this cell. Now, what do these invaginations do? They have this ability of getting in or taking in antigens that are found on the lumen, inside the lumen of the intestinal tract, and transporting these antigens inside them and into the lymphocytes that are found inside them. The last type of cell is also known as the lymphocyte cell. That is the lymphocyte cell, and the lymphocyte is in close association with the M cells. So whenever the antigens, so these are the antigens that go inside this M cell with the process of endocytosis, and this leads to these antigens going in. So these are the antigens, and they sort of go inside here, and they get cross-checked by the M cells, and then they reach the lymphocytes. Lastly, it is also very important to mention that the core of a typical villi is supplied by something known as a lacteal. So this entire structure here is a lacteal. And a lacteal is basically a lymphoid vessel that is found inside the core, and it's supplied by blood vessels. So we have blood vessels that course through this lacteal, and then we also have certain or the incoming of the entire muscularis mucosa to inside these lacteal vessels. So other than those villi that we saw before, we have another structure that is found inside the intestinal lumen, and that goes through the intestinal lumen into this mucosa of the entire intestinal tract, which is known as the crypts of Lieberkühn or gastric pits. Now, these gastric pits, there are similar types of cells that were found in the villi and also inside the gastric pits, namely the enterocytes. Then we have the goblet cells, but then we also have some specialized cells, namely the Paneth cells. Paneth cells, if you look at it closely, you can see that they are small cells that are located basally in the gastric pits, and they have this ability to secrete an enzyme known as lysozyme, and also they secrete some tumor necrotic factor or TNM. So they mostly have a defense mechanism of function, and they help protect the intestinal lining from the attack of other microorganisms. If we look into these crypts more profoundly, we can also notice that more basally we can find the stem cells. And stem cells have this responsibility of giving rise to epithelium cells and neuroendocrine cells. So we know that a typical stem cell gives rise to a neuroendocrine cells. So these are neuroendocrine cells, and there are different types of neuroendocrine cells. They have the ability, they're actually classified according to their ability to either secrete gastrin, cholecystokinin, or secretin. They also act as stem cells, and they can give rise to different enterocytes or also epithelial cells of the small intestinal tract. Let us go back again into the mucosa. Now, after the epithelia, we have the lamina propria. And the lamina propria is made up of something known as, so this right here is known as the plexus of vessels. So we have plexus of vessels that provide nutrition for the underlying epithelia, and it also consists of a rich vascular plexus and lymphoid tissues, cells like fibroblast cells, connective tissues, mast cells, capillaries, lymphatic vessels, unmyelinated nerve fibers, and plasma cells. Then we have the mucosal associated lymphoid tissues, or over here we can call it gastric associated lymphoid tissue because of course we are in the gastric region. Then we have the submucosa, and later we have the muscularis mucosa. There are certain pits known as the submucosal Brunners, Brunners, Brenner's glands. Now, these submucosal Brenner glands are only, so for example, this is the stomach, they're only found in the duodenal region of the stomach, and they extend all the way from the submucosa into the level of the muscularis. So till here, they sort of extend all the way into the mucosa. Their main function is to maintain an alkaline pH of 9 actually on the scale. So it maintains a pH of 9. So it secretes alkaline substance into the lumen of the intestinal tract. Then we have the muscularis externa. That's the muscularis externa right there. And then, so this is the muscularis externa, and then we have the serosa. So the muscularis externa is made up of circular, longitudinal, smooth muscle cells. And it's also important to remember that there are certain dispersed cagal cells here too. So these are the cagal cells, which are sort of like supply a nervous and sort of give the ability for the entire intestinal tract to contract and have this pyloric type of movement.